Hello, and welcome to the lecture on cost of living. In this lecture, we're going to be looking at the CPI, which is the Consumer Price Index. So we're going to calculate the CPI, and then we're going to calculate inflation using CPI. Now, one thing that you'll notice about this is that the process is nearly identical to the process that we just used for our GDP deflator. So the big difference between the GDP deflator and the CPI is the goods that are included in the basket. When we're thinking about the Consumer Price Index, it is going to include consumption goods. And not just consumption goods, but typical consumption goods, which means that the basket will have things like food, it will have shelter, clothing. It's not going to have items like big trucks, like tractors or industrial equipment. Those would fall under investment. Some consumption goods are also imports. So it's going to be a much smaller basket compared to the GDP deflator. But oftentimes when we hear about reports on inflation in the news, this is going to be CPI inflation. And that's because consumers don't really care about the price of things like tractors and heavy-duty equipment going up. But they do care about the price of food going up. So this is the typical consumer basket in 2017. We can see that each of these categories is part of a typical consumer's consumption. We see that there is shelter, which makes up a fairly large portion of our budget, of our expenditure. We've got food, transportation, household operations, clothing and footwear. Right. Notice how these particular goods and services that are included in this basket are just consumption goods. Similar to our GDP deflator, we've got a CPI, which is the current cost of a base basket divided by the base cost of a base basket. Notice that in this particular case, just like we had with the GDP deflator, the base basket is the same on the top and the bottom, i.e. it is a base basket. So again, when we're calculating the CPI, what we are calculating is a price ratio. The inflation rate is exactly the same as we would calculate for the GDP deflator. Here we have our basket for the CPI. Notice that it is only containing consumption goods. In this case, it just looks like it's containing food. However, it's different than the basket that we used for the GDP deflator. So since the basket is the same year after year, that is, we use the base year basket. So notice in the denominator, we've got the price in 2012 multiplied by the basket in 2012. And then in the numerator, we have the price in 2012 multiplied by the basket in 2012. And when we want to move on to 2013, the only thing that is changing is the price in the numerator. Right? So the basket remains constant. That is, the government chooses a basket, and that basket is used year after year after year. And then there will come a point when the government might change that basket and then use it again for a number of years. But this is something that makes the calculation a little bit easier, in that all we're doing is changing the price in the numerator, whereas everything else remains constant. As we can see, in a virtual sense, not a literal sense, but in a virtual sense, the basket is essentially canceling out on the top and the bottom, and this leaves us with that price ratio. So let's take a look at our calculation here. These are the formulas that we're going to be using, and we will use them in a numerical example. So here we're given our basket, which in this case is going to include fish and rice, and I am saying that 2013 is the base year. When I see that 2013 is the base year, I like to identify my basket. So this is the basket that I'm going to use every single year. And notice that all I have to do is calculate the cost of this basket in the different years, which means that there's no such thing as a real CPI and then a nominal CPI cost. Ultimately, we simply have a cost of the basket. So for 2013, I'm simply going to take 60 times 12 and 22 times 100, and that gives me 29.20. So that is the 2013 cost of this basket. And of course, the basket that I'm using as my base basket is the consumption goods of 2013. Moving to 2012, I am just simply going to use my prices in 2012 and multiply them by my quantities in the basket of 2013. So 50 times 12 multiplied by 20 times 100, giving me 2,600. And if I use these values in my CPI, I end up with a value of 89. So why don't you take a quick moment and calculate your 2014 CPI. Actually, I guess before we do that, I'm going to just do a quick calculation of the inflation rate for 2013. Remember, when we talk about the inflation rate for 2013, I am talking about 2013 divided by 2012. So we have 100 minus 89 divided by 89, giving me 12%. Or, if you recall from our calculations that we do when we're doing percentage changes, many of you will probably just take 100 divided by 89. This will give you a value of 1.12, which you know is equivalent to a 12% increase. So, getting back to what I had just mentioned earlier, how about you go ahead and do the 2014 calculation? So if you need to pause your video at this point, I would recommend it. For your 2014 calculation, you should have gotten a cost of the basket of $32.20, and this gives you a CPI of 110.3. And of course, if the CPI is 110.3 in 2014, my inflation for 2014 would be 10.3%. Let's compare the GDP deflator and CPI. Both of these are going to be able to give us some of the same information. That is, we can calculate inflation using either the CPI or the GDP deflator. And we know that inflation is generally the result of an increase in the money supply. Which means even though we are using different baskets, we will find a similar trend with CPI inflation versus GDP deflator inflation. And here we can see that. We see that the blue line is the GDP deflator. We see that the purple line is the CPI. And we see that in general, there is a trend which both of these values follow for inflation. There's a little bit of variation, but for the most part, we see the exact same trend. As I said, this would be expected since inflation is driven by the money supply, and that money supply increase is going to cause the price of all goods to change by essentially the same amount. The difference between the GDP deflator and the CPI is, well, there's essentially two things that we have here, as you can see. The first, the GDP deflator uses a production basket, and the CPI uses a consumption basket. So if you want to write down the short version of the first difference, it is production versus consumption. And then if we look at the second difference in the CPI and the GDP deflator, the first or the big thing is that the GDP deflator changes every year. So that basket is always the current year. This is why we've got to do extra calculations. Whereas the CPI basket is the same year after year, which is actually why the calculation is so much easier or has fewer steps. So, in short, the second difference is changing versus constant. Now, there's some problems that we have with the CPI. A lot of it arises from the fact that it is a constant basket. So we have three problems that we need to deal with. The first one is called a substitution bias. Now, in our first year, imagine that we have prices for apples and bananas. And we can see that because of this, we're going to have 3 apples and 3 bananas in our basket. So this volume or this amount of the goods is essentially telling us our basket size. Now, imagine in year 2, if we look at the prices, imagine if the price of apples has gone up a lot. Well, if this is the case, then what we're going to do in year 2 is we're going to substitute towards bananas. That will save us some money. Now, because we're substituting for bananas, you can see that in reality, our basket of consumption has changed. However, in the calculation, the basket of consumption has not changed. This means that the year 2 cost of the basket is going to be overestimated. Right? Because we've got essentially this big price multiplied by 3 apples in our calculation, and we have the small price multiplied by 3 bananas in our calculation. When in reality, we've made a substitution to push down the price of our basket. So, by using the same basket, in this case, the inflation rate is going to be overestimated. We also have the problem with introduction of new goods. So every few years, the basket actually has to change. Right? So even though it is a constant basket, it can't be constant forever because we introduce new goods into the economy. So in 1990, if you were coming to school, you would have been purchasing things like books and a notebook. Right? Textbooks and a notebook. Whereas in the year 2000, a lot of students were coming to school with computers. So how can we actually compare these baskets over time? Right? What is the cost of living given that our basket is now different? So this is going to cause some issues with the measurement. And again, we don't have to worry about this with the GDP deflator because the GDP deflator automatically changes as the production basket changes. But for CPI, it is a problem. And then we have the unmeasured quality change. And this can arguably be a problem with GDP deflator as well. But we generally just associate it with the CPI. When we're talking about things that change over time with respect to quality, that quality change is not included in the calculation, right? So here we have an old refrigerator versus a new refrigerator. Well, that refrigerator is in the basket back in 1950, and it's also in the basket in 2020. So even though the price has gone up, i.e. the basket is showing inflation, it actually is overestimating the amount of inflation because the refrigerator is higher quality. So you're not just paying a higher price because the price of the refrigerator has gone up, but some of that price increase also includes higher quality. So this is not going to show up in the CPI measurement. So how can we measure a change in a CPI basket if we only have a price change in one of the categories? So here is our Canadian basket. And what I want to do is I want to ask myself, what would happen if, let's say, the price of shelter went up by 10%. Well, if the price of shelter goes up by 10%, then that means the entire basket is going to increase in price by 2.68%. So I'm taking 10% of 26.8. Right? So if shelter goes up by 10%, my entire cost of living will go up by 2.68%. So let's do some examples here. How much does CPI change with each of the following price increases? What if there is a 6% increase in shelter prices? Well, just as I showed you or discussed, if we have a 6% increase in shelter prices, that means that the entire basket is going to go up by 1.608%. Right? So if my basket currently costs $200 and the price of shelter goes up by 6%, that means that my basket is now going to cost $203.2. It's going to go up $3.20. If there's a 10% increase in transportation prices, that means that the price of my entire basket will go up by 1.91%. And if there's an 8% increase in food prices and a 4% increase in recreation prices, and these two events happen at the same time, then I'm going to get a 1.748% increase in the price of my basket. So, CPI measures the price of a typical consumer basket. Essentially, what we are able to do with this information is calculate the inflation rate based on the consumption basket. So for a typical consumer, how are prices changing? As per usual, I'd like to thank Pixabay and some of the other companies out there that have given free photos available for people to use. So thank you for listening to this lecture. I hope you've learned something, and we will see you in the future. Thank you.